So today, I'll be teaching you guys modular arithmetic. And this is one of my favorite topics in number theory because it's a topic that's not usually discussed in school math, but is really cool and really useful in competition math. So I hope you guys understand this after looking at my videos. So firstly, let's say we have two integers a and b. Two integers a and b. And let's say we have some positive integer m, where m is not equal to 1, then if a and b have the same remainder when divided by m, then we say that a is congruent to b modulo m. So what does this mean? What does this symbol mean? And what is this mod? And what is modulo? And what is modular arithmetic? So basically modular arithmetic is a system where integers with the same remainder when divided by some positive integer m, where m is not equal to 1, are considered congruent. So in this system, we call m the modulus of the system. The modulus of the system. So let's write that. The modulus of the system. And when we're working with the system, we say we're working with integers modulo m. And for short, I say mod m. So here a and b have the same remainder. We said that a and b have the same remainder when divided by m. So we say that a is congruent to b modulo m. So let's try out an example. So let's work with modulo, give me a random number, 3. So 2, in modulo 3, in the system of modulo 3, 2 is congruent to 5, because when 2 is divided by 3, the remainder is 2. And when 5 is divided by 3, the remainder is 2. So we say that 2 is congruent to 5, modulo 3. Then what about number 8? So 8 also has a remainder of 2 when divided by 3. So 8 is also congruent to 2 and 5. And same goes with 11, which also has remainder 2, and 14, which also has remainder 2 when divided by 3. So these all have the same remainder when divided by 3. So we say that they're all congruent modulo 3. So we got a basic understanding of how this thing works and what modular arithmetic is and what these weird symbols mean. So what do you notice from this though? So let's take the difference of any two congruent numbers in modulo 3. So 2 and 5, they're congruent. The difference is 3. And 8 and 14, they're congruent. And they have a difference of 6. And 5 and 14 have a difference of 9. What do you see from this? So if we take the difference of any two numbers that are congruent in modulo 3 is a multiple of 3. That's pretty cool. So what do you know from this? So if a is congruent to b if some integer a is congruent to some integer b modulo m, then we know that this tells us that a minus b is a multiple of m. But why though? Well, this is pretty important info, but why? So let's say that a and b both have the same remainder when divided by m. So let's say that remainder is r. So let's write that here. So firstly, a can be written as a multiple of m plus the remainder. So we can write that multiple as some integer k1 times m plus the remainder. And b can be written as a multiple of m plus the remainder. So some integer k2 times m plus the remainder r. And let's subtract these equations. Oops. Let's make that a bit neater. So subtract these equations. So we get that a minus b is equal to k1 times m minus k2 times m. And these r's cancel out, so they're gone. And we can factorize out m on this side. So k1 is an integer and k2 is an integer. So k1 minus k2 is an integer. So m times an integer is a multiple of m. So a minus b is equal to a multiple of m. So we got that. So we got y. So now we know y. So we just proved y. If a is congruent to b modulo m, then a minus b is a multiple of m. And we can actually write this. We can actually write this expression as a modular equation. So we can write that a minus b is congruent to 0. Oops, let's make that thing a bit neater. It's congruent to 0 mod m. So what it means for a number to be congruent to 0 mod another number, it means that the remainder is 0 when this number is divided by this number, which means that this is a multiple of this number. So basically this is saying that a minus b is a multiple of m. So be aware of this. So if something is congruent to 0 mod something, then that is a multiple of that number. Okay. So now we have our basic knowledge of knowledge of modular arithmetic. We're doing pretty good. So first let's erase this. Okay. So now we're going to learn the basic rules that we have to know about modular arithmetic. So if we have that a is If we have that a is congruent to b mod m, then a plus k is congruent to b plus k mod m, and a minus k is congruent to b minus k mod m, and a times k is congruent to b times k mod m, where k is any integer. So what does this tell us? So it tells us that we can add, subtract, or multiply any integer to both sides of a modular arithmetic equation. So, but why does this work though? So if we have that a is congruent to b modulo m, then we know that, as we discussed previously, a minus b would be a multiple of m. So a minus b would be congruent to 0 mod m. Then let's try taking the difference of these two values. So a plus k minus b plus k. And if we simplify this, we get that the k's cancel out to get that this is equal to a minus b. And we know that a minus b is a multiple of m. So the difference, so a plus k minus b plus k is equal to a multiple of m. So the difference between these two values is a multiple of m, which means that I forgot to tell you. So we discussed that if a is congruent to b mod m, then a minus b is a multiple of wait, let's make that a bit neater. Oops. Is a multiple. Wait a sec. Is a multiple. Wait a sec. Wait. Okay. A minus b is a multiple of m. So if a is congruent to b mod m, then a minus b is a multiple of m. But in the other way, if a minus b is a multiple of m, then a is congruent to b mod m. So it works both ways. So if we know this, then this is true. If we know this is true, then this is true. Okay, so we have to know that. Forgot to tell you about this. I'm sorry. So we know that. So from what we discussed here, we know that since the difference between these two, since we know that a plus k minus b plus k is a multiple of m, therefore a plus k is congruent to b plus k mod m. So there we go, we proved this. And we can actually prove this in a similar manner. So try it out yourself, or we can do it together. So a minus, the difference between these two values, a minus k minus b minus k, is equal to, if we simplify this, these k's cancel out, to get a minus b again. So the difference between a minus k and b minus k is a multiple of m, which means that a minus k is congruent to b minus k modulo m. Sweet, we proved these two things. What about the multiplying thing? So a times k, so the difference between a times k and b times k would be, we can factor out k to get this. So this is a multiple of m, because a multiple of m times any integer is still a multiple of m. So the difference between a times k and b times k is equal to a multiple of m, which means that a times k is congruent to b times k modulo m. So now we proved and understand why we can add and subtract and multiply any integer on both sides of a modular equation. Sweet, we got it. Okay, so now we're gonna learn one of the most important rules in modular arithmetic, the addition and subtraction rule. The addition and subtraction rule. The addition and subtraction rule. So it's fairly easy. So we have that a is congruent to c mod m, and b is congruent to d mod m. Then we get that a plus b is congruent to c plus d modulo m, and a minus b is congruent to c minus d modulo m. So this is the addition rule because you add, and this is the subtraction rule because you subtract. Okay. So we got the rule, but why does this work? So usually when we look at rules, we're not going to just go over it. We're going to look at why it works. Okay? So let's try proving these two rules. So if a is congruent to c mod m, then we know that a minus c is a multiple of m. So a minus c is congruent to 0 mod m. And similarly, b minus c will also be a multiple of m. So it's congruent to 0 mod m. So let's first look at the difference. So we know that if we add two multiples of m together, we again get a multiple of m. So this is a multiple of m, this is a multiple of m. So if we add these two values together, we're going to get another multiple of m. So let's first add these two expressions. So a minus c plus b minus d. And if we rearrange the terms, we're going to get a plus b minus c plus d. And this is a multiple of m, so this and is equal to this. So this is a multiple of m. But then, again, as we discussed previously and used previously, we know that if the difference between two values is a multiple of m, then those two values are congruent modulo m. So here a plus b minus c plus d is a multiple of m. So a plus b and c plus d are congruent to each other modulo m. So we proved the addition rule for modular arithmetic. Then what about the subtraction rule? Well, it works in a really similar fashion. So again, similar to how if you add two multiples and get a multiple again, if you get the difference, or like the subtraction of two multiples of m, then you get another multiple of m again. So a minus c minus b minus c will be a multiple of m. So because a minus c is a multiple of m and b minus c is a multiple of m. So let's write that. A minus c minus b minus d. And if we rearrange the terms, we get a minus b minus c minus d in brackets. And this is a multiple of m. This is a multiple of m. So the difference between a minus b and c minus c is a multiple of m. So a minus b is congruent to c minus c modulo m. There we go. We got it. We got the addition of subtraction rule, and we proved it. So far we learned the basics of modular arithmetic. So like what these notations mean, and we know that if a is congruent to b modular m, then the difference between then a minus b it will be a multiple of m. So it will be congruent to 0 modulo m. And we know that we can add and subtract any integer on both sides, add and subtract or multiply on both sides of a modular equation. And we also learned the addition and subtraction rule, where if a is congruent to c modular m and b is congruent to d modulo m, then a plus b is congruent to c plus d, and a minus b is congruent to c minus d modulo m. So we've completed the first part of the introduction to modular arithmetic. So that's the end of part 1, and see you in part 2.